Alright guys, hello again, and this time I want to show you how to solve this circuit for every single quantity we have associated with it. So we do have the R total, the total resistance. We do have the I total, the total current that flows through the circuit. So that means it's the current that flows out of the battery and comes back into the battery. Then I want the voltage drop of this resistor and the voltage drop of that resistor. Okay, so first I'm going to start with R total. R total is a fairly easy thing to find in this particular case. We just need to use the formula for resistors in parallel. So if you guys remember, that formula was 1 over R total equals 1 over R1 plus 1 over R2. Okay. Well, we actually already found that in our previous problem, but I'm just going to do it again just for kicks. So first I need to find 1 over R total. This is going to be my step 1. So that is going to be 0.02. And after that we find the R total itself. Which is of course 1 over 0.02. And we already found that that is 50 ohms. Okay, we have the R total. That means we can find the total current. That's very straightforward. That is exactly the same way we did this last time when we had resistors in series. So now I can use my Ohm's law. So I have I total equals to voltage of the battery over R total. Okay, that's a pretty straightforward formula. So all I have to do now is plug in some numbers. And in this case, I'm going to have 2 volts over 50. That is exactly 0.04 amps, or if I'm doing my conversion, 4 milliamps. A very nice current. Now the next thing that I have is I1 and I2. Well, I should be able to use Ohm's law for this one. Remember Ohm's law? We've got our wonderful triangle, voltage over current times resistance. Well, I know that Ohm's law actually talks about voltage drops, and it's always the voltage drop of the resistor is the current that flows through the resistor times the resistance. So it would make sense that I would look at Ohm's law to get my current. The problem is, of course, I don't know those voltage drops. So I don't know 2 out of 3. That's not good. Unless I use KVL. Remember what I said? KVL is the sum of the drops around the loop. So let's consider our loop 1. So this is going to be my first loop. So the electron comes out of the battery. All of them are going together up until this point, and then some of them go into this resistor, and they'll go back into the battery. This is my loop 1. And I know that voltage of the battery, according to KVL, has to be equal to the sum of the voltage drops, of which I have exactly 1. So literally, KVL tells me that the voltage drop of this one equals to the voltage of the battery, and that one is just 2 volts. Well, that was an easy one. So V of R2 is just 2. Equals to voltage of the battery is just 2 volts. Now guys, take a look at the other loop I have. This is my second loop. Once again, they start all together, but this time they go over here. Go through the resistor, and then come back into the battery. I have exactly the same deal going on here. Voltage of the battery around this loop equals to the sum of the voltage drop. And I have only 1 voltage drop in here. I just have V of R2. All right. Well, that is easy because that is also 2 volts. So in my equation over here, I'm just going to add, well, I actually put in V of R2 here. Interesting. V of R1. All right. So that was very, very simple, and I found those two very, very quickly. So the last but not least thing I need to do is I need to find my current. And you can see that my currents are going to be exactly the same because they have exactly the same resistance and exactly the same voltage. So my current, I1, equals V of R1 over R1. Okay, so I can plug in some numbers now. So this is just 2 volts over, I believe I had 100. That's right, I had 100 ohms equals 0.02 amps. Now, for my last current, I'm not actually going to use the Ohm's law. I'm going to use KCL because KCL says total current, all of my currents, have to be equal to the sum of the little currents. So this is just I total equals I1 plus I2 in this case. And I already have the I total. I already found it. It was 4 milliamps. And this one is, of course, 2 milliamps. I need to convert this. So when I look at this expression, it ends up with I2 being equal to I total minus I1. That's very straightforward. So this one is just 4 minus 2. Now notice that since all of my units are in milliamps, I don't really need to convert. If all of your units are the same, they have the same unit and the same prefix, then you don't have to convert. So I get 2 milliamps. Very, very, very straightforward.